To factor a polynomial that is a difference of two squares. Here's an example. You have x squared minus 9. First you have to recognize that it is a difference of two squares. So to do that you have three things you have to look for. One is the sign in the middle. If it's not minus, it can't be a difference of two squares. A difference is subtraction. Sum is addition. So you have to look at the sign. And then number two, make sure your first term is a square. And then three, make sure your second term is a square. If all three of those have been satisfied, then you can do this very easily. Factor this by using the rule for a difference of two squares. X squared is a perfect square. What is its square root? What's the square root of x squared?
1.
No, not 1. X, yes, because you multiply x times x to get x squared. So the square root of x is x. And once you recognize this is a difference of two squares, you immediately set up two sets of parentheses, and then the square root of the first term goes twice in the first part of each set of parentheses. Now, you have 9. 9 is a perfect square. What is the square root of 9? 3. Put the 3 at the end of both sets of parentheses. And then the last thing you do is put 1 minus sign, 1 plus sign. To check that this works out, you can go back and multiply these. What is x times x? X squared. X times x is x squared, and then x times 3 is what?
9.
X times 3?
Oh,
3x. And then now start back over here. What's a negative 3 times x? Negative 3x. And what's a negative 3 times a positive 3? Negative 9. Now go back and simplify. You have 3 x's and you're taking away 3 x's. How many are left? 0. So the only two terms that are left are x squared and minus 9. So it does work out. This is your final answer. X minus 3, x plus 3. First of all, do we have a minus sign?
Yep.
Is 16x squared a perfect square?
Yep.
Is 25? Yes. So here's what we do. Set up two sets of parentheses. What is the square root of 16x squared?
4x.
4x, yes, because the square root of 16 is 4, and the square root of x squared is x. So you put that at the first spot in both sets of parentheses. What's the square root of 25? 5. And then what do I put in next? Plus and a minus. 4x plus 5, 4x minus 5. The answer for this one should be 7x plus 10, 7x minus 10. Alright, the answer on this one should be x plus 6 and then x minus 6. On this problem, 4x squared minus 25, what should the answer be?
2x, take away 5. Yeah, minus 5. Then parentheses 2x plus 5.
Yep, that's it. 2x minus 5, 2x plus 5. On this problem, is 10x squared a perfect square? No. So here's what you have to do. If you're going to use the difference of two squares, then you have to be able to factor out something. What can we factor out from 10 and 40?
10.
A 10. You could take a 5 out, but that wouldn't give us a perfect square. If I factor out a 10, then I'm left with x squared minus what? 4. So now you can do the difference of two squares on this, but do not forget to include the 10 out to the left. If you don't put it in there, then it's wrong. So what should the difference of two squares part answer be for this?
X minus 2, x plus 2.
That's it. You'll have 10 times x minus 2 and then times x plus 2. The solution here is to factor out a 6 first and be left with x squared minus 9. 9 is a perfect square. So you'll have 6 times the quantity x plus 3 and then times the quantity x minus 3. For this solution, you have a perfect square there and there. So it should be 4x plus 9 and then 4x minus 9. Okay, on this one, test to see if you have a difference of two squares. You have a 3x and an 18. That's not going to work out as a difference of two squares. You could take out a 3 from both of them and be left with x squared minus 6. But this is a perfect square. What about 6? No, but you can't go any further than this. That would be the answer.
What?